So welcome to my channel once again. I welcome you. I believe you have been quite okay for any other challenges you could have faced. We surrender them to God. If you are not a believer, you ought to believe. We have been looking at the MySQL constraints. One thing to note is that the codes I write or that we are practicing, they also apply to MySQL server, they apply to the Oracle database SQL, they also apply to Access or Microsoft Access. There is not much of a difference in most cases. In MySQL we can simply say, for example, id integer, and then we say maybe primary key, whereas in MySQL server Oracle we could simply write it as id integer, and then we shall put the primary key later. We can simply say primary key, then we put it in the brackets as id. Majorly that would be the difference, but the structure, the understanding, what it does is the same. MySQL server, Oracle, MS database, that is how they are. So today we are going to talk about check constraint, and we are saying that it is used to limit the value range that can be pressed in a column. If you define a check constraint on a column, it will only allow certain values for that particular column. The same applies to defining a check constraint on the whole table. So we can quickly say that we are going to talk about the check constraint. Check constraint, that is what we are going to talk about today, and we can begin by creating a table. We can say create table, of course after selecting our database. Create table, we can maybe call this employees, and we are saying that in this table employees, we can say in this table employees we can choose to say that maybe we have an ID that is an integer and not null. We could also say that it is a primary key, like that. And then we could also say that maybe we have, let's say, first name, or we have full name. We have full name, that is a vulture. A full name vulture, let's say, of 50 characters. That would also be quite a very long name. We could have maybe age as an integer, and now we want to create a constraint here called check. So we can say that check, and then we put the constraint in a bracket, that age, meaning we are creating a constraint on a column called age greater or equal to 18, greater or equal to 18, like that. So we can terminate. We hope, since we are using the same database that has got many tables, we hope that we will not find issues with the database existing. There it is, we have created it. Now we can test that particular constraint. Now we can say testing the constraint. We can say insert into employees values, that into employees values we can say 1 comma full name is Benjamin Tarimo, Benjamin Sky Codes. You can find that on my official YouTube channel, Benjamin Sky Codes. We can test the age by saying 17, and we know that 17 is a number less than 18, which means if the check constraint was here, the check constraint is saying the age should be greater or equal to 18. Now that it is less, it should not allow this guy to be inserted into our employees table because maybe he's underage, and that is exactly what it does. When we say 19, then we expect this person to be, we can even leave this at 17, then we can copy it and then we say 19. But the other one refuses, we know won't accept, creating our own future notes, won't accept, then we can say accept. So we could even, when we run this, we can see that it has accepted, meaning our constraint is working. Another thing you need to know about check constraint is that it is used or acts as a boolean, and the values to be inserted in that column must satisfy that expression you have created. Let us look at another example that we shall continue using. We can say another example. So let us assume we have a table called products. We can say create table products, and this table has got what we call a product ID, which is an integer, primary key. I would want to check what my settings are here. Okay, primary key and not null. Then we could say that it has also got product name, like that, with a voucher or a variable character, and of say the products. They are not usually very long names because very long names don't sell. People need to remember the name of the product. We can just say 20 for the sake of it, and this is also not null because the product must have a name in our database. Anyway, whether in small letters or capital letters, this would work, but by standard or convention, we put them in capital letters. Now we can even put it here just for us to be able to see it. We can add in another one called unit price, because we know every product has got a unit price. Okay. I hope at your end you will be able to follow proper rules of naming these. For example, one of these would be to say unit price, like this. Again, by convention, that is what it is, unit price. And since this is money, it can be in cents, depending on the type of country you live in. Especially there are some countries where a figure is a whole number, but in most countries currency is also in cents or points. So we can pick up a data type called decimal, like that, and then we say 10 comma 2. What do we mean? Even if we did not put a 10 here and we left it blank, it would still, the default would be 10. If we didn't put a 2, the default would be 0. What does that mean? That we shall cover a tutorial about data types and explain this more. So just know that this is decimal. This would be 10 characters before it can accept up to 10 characters. That is what you are saying. This is the limit. It can accept up to 10 characters before a decimal point. So you would, for example, have 1 2 3 4 5 6 7 8 9 10, then dot 1 1. That is what it means. Why the two are the decimal places. We shall expand this when we come to the tutorial about the data types. So now we want to create a check on the unit price, just like we created the check on the age. One of the ways we can say check unit price, check unit price. It should obviously be greater than 0, because we cannot have a database with a product that has no value. Okay, the unit price at least should be greater than 0. So logically it makes sense. Now we can try creating this table, hoping that it does not exist. We have created our table, and we can also choose to test this by looking at whether this gives us what we are looking for. We can say insert into products, product ID. We can say maybe we didn't set a number, maybe 123, comma, product name we can say soda, and we are looking at unit price. We can say maybe the unit price is around 1,000. I'm talking about Ugandan shillings. You can say it is, let's say, 1,000, maybe dot 00. Those would be our saints. But we can test this by supplying a 0, for example, and we cross it out like that. You can say, didn't set the number of insert into products. Okay, values, products is the table, values. So now when we run this query, it does not enter this. Why? Because it says there is a check variation, a rather violation, meaning the price must be greater than 0. We can try that again by simply saying maybe this is 1,000 dot 00, and then we try running this. When we run it here, it is accepted. When we select from this table, select or from products, then we can say that this is our result. Okay, so but there is another way we can for example, assuming we wanted to create the name of that constraint. Remember, we've been creating it even on foreign, on primary key, on unique. We created the name because it is easier to have a name that at a later point you can refer to when you want to delete, when you want to alter the table and stuff like that. You want to drop that constraint. So we can say, we can first and foremost, let us drop that table, drop table products. We want to use the same thing. We are a bit lazy to think beyond this. The table is dropped, so we can come back here, copy this. We can say giving a constraint name. So we can paste this one here, and then we say just right here after this, we can now say constraint, then we give it a name. That this name can be maybe unit dash price, like that. Dash is not understood properly, we can call it unit price. So that will be our the name of our constraint, and everything else we can leave it as it is. So when we make that option, we can create this table. The table is created also. Now we can choose to violate it here. We can copy this or insert it here, creating a violation. We paste this and simply supply a 0 here. When we run this, we now see that check constraint unit price is violated, whereas this was products check products underscore check underscore 1. So that name has been picked. Now we can choose to insert in a proper value that will be accepted because it is not violating any constraint. Now, whereas this is also a good thing, it has got a downside, because a product to be entered in a database, you should require that it has a unit price, because it is that unit price that then you can use to multiply together with the number of items the person is purchasing, and you get the total price of a product. So you must have a unit price. Now we can test that this by default, if the check is false, then it creates an error. Okay, if this value is not greater than 0, then meaning it is false, then it is an error. But we can also manipulate it by supplying, for example, by supplying NR value here. Okay, when we say NR here, we can do something like that and try to test it. NR value is created. When you select from products, you will find that we have created a product that has got NR unit price, which is in fact an error, but then check also allows it, meaning to fix this you needed to have created a table here. Unit price, we should have said while creating this table, where was it, we dropped that. While creating this table, we should have said not null. Then by default, the fact that we have said not null, it would not allow null values of unit price. So now you see how not null is an important constraint, because it eliminates these errors. You would not insert in a null function, or rather a null constraint, or a null, you do not define that as a default null, yet you have said not null. Another topic or subtopic you can look at under check constraint is if you wanted to create a constraint on multiple tables. We can again use the same table, just because we are lazy. We can drop the table here. Once the table is dropped, then we can copy it here. Can copy this. We can say creating a check constraint on multiple columns. then we paste this here and we edit it. So we have int primary key not null, we have product name, we have unit price, and we are saying not null. We shall come back to this later. We are saying that check unit price to be greater than 0. Then comma, we can also say that the discounted price, when you expect that you might have promotions, we can say discounted underscore price, which would be the right way. It is also a decimal because it is a price, or currency. We can use the same limitations, 10 on 2. And we are also saying not null because we have seen dangers of leaving it empty. Then we can also say check in here discounted price. You can copy this, check discounted price. We also need to say that it is greater than 0 because you cannot have a 0 value there. Let me see, hope this is not a point, should be a comma. And then we need, we are creating a table, we need a closing bracket, but that is not all. We can also say that check to see whether the discounted price is less than the unit price. You need to be careful while typing this, otherwise you will create a lot of errors. So here we are saying that not null, check discounted price whether, okay, in your mind keep having the word whether or if. So you need to be careful in while applying this. I would let us put some spaces, much as really not necessary. So we are saying that create a table product, that is the ID, that is the product name. We have a unit price, and we are saying check to make sure that the unit price is not check the unit price whether it is greater than 0. If it is not greater than 0, it will refuse the insertion or deletion or update, whatever it is that you are trying to do, it will refuse. We are also creating another column of discounted price, and we are saying not null, but we could have left it aside because not every commodity has got a discount, so we can as well not use this. We can just leave it like that, unless we want to apply it to certain product, like you had a table of each product you have. Maybe you have a soap, you have sodas and stuff like that. Then you could apply discounted price not null if you know you're going to sell them at a discount. So we are saying that the discounted price, remember discounted price, you have a unit price, let's say 1000, and you are saying that you are discounting it, meaning you might be selling that item at around 800, and you are saying that it should also be greater than 0 because it cannot be at 0 price, it's not a giveaway price. And you are saying check if discounted price is less than the unit price, because if each unit is 1000 at discount, it could be a discount of a total or just a discount of the unit price. Right now we are comparing it with the unit price, so meaning a discounted price should be less than a unit price. It cannot be, the unit price cannot be 1000 whereby the discounted price is 1100, unless you are dealing with totals. But the fact that we are dealing with the unit price, this is what you would have. Now What does this mean? Check unit price is what we call a column constraint. Discounted price is also a column, meaning check is discounted price is also a column constraint. But when it comes to check discounted price less than unit price, this is what we call a table constraint. So whenever you are entering data, even if it was to match this, that it is greater than 0, this will also be taken into consideration. Okay, it will also be taken into consideration that the data you enter must satisfy that third condition, which will be a table condition. So we can pick this information. For example, I believe it is new since we dropped the table. We can say that we have that ID. So we can say that this is the unit price 1000, such that we are not creating any error. Or we can begin by eliminating errors, creating them on purpose. 0, then also 0 for the discount. We need to find out. Okay, so now when we run this, you can see we have multiple errors. Let us assume this unit price is 1000. I thought by default, if you don't put a dot something, it will just create it as 0, but let us use them here. When we run this again, we run into another error. Let us first create this table. I think we hadn't created it. We are saying column check constraint products, reference is other column. So we can see where the complaint is. We need to have put a comma here. We are saying comma discounted price, comma check discount. We can rerun, and now we are safe. So when we have all these as zeros, we shall create a similar error. Because of violation, we can make one of these to be correct, because it is greater than 0. We run, we should be able to run into another error that is testing this to be greater than 0 and finding this as 0. We can prove by creating a chaos. Let us say that now this is 1100, like that, .00. When we run this value, it also refuses. It is checking the product 3. You can see the first one was this, the second one was for this, the third is for this. It is telling us that this value cannot be inserted because the discount price has become greater than the unit price. Yet the discount price is got from it is a percentage of the unit price, so it must be lower. We can do that. Let us say this is 800, and we run again, and it is accepted. So that is check for all these. We can look at another sample of what this means.